Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on electricity from March 2022, Paper 2, Variant 2. In this question, we will discuss some very important concepts, and those concepts are very common in past papers. Means those concepts are frequently asked in past papers. So try to listen carefully and try to improve your understanding of electricity. For our question number 6, it is given to us the ends of a metal resistance wire are connected to a battery of electromotive force 8.0 volts, and battery has no internal resistance as shown in figure 6.1. If we look at this figure, this is the resistance wire and this is connected across terminals of power supply. So this is our resistance wire. EMF of battery is 8.0 volts. It is also given to us the power dissipated by the resistance wire is 36 watts. We need to calculate current in the resistance wire. Let's try to write down what is given to us. So the best way to start this question is write down what is given. And this is not only true for this question, you can use this one for any problem in physics. So we will write down what is given. In this case, power dissipated by wire is given. So simply we can write down this is given to us. Now we need to find out what else we can find out from the given data. Now if you look at this wire and if we connect a voltmeter across this wire, we can find out value of V, means the potential difference across this wire, and that potential difference has to be equal to 8.0 volts because this battery has no internal resistance. If it has internal resistance, we also need to consider internal resistance of the battery, but in this case it has no internal resistance, and these wires, these are also ideal wires, means there is no potential drop. So these are ideal wires, so there is no potential drop. So it simply means that all the potential is dropped across this resistance wire. So the reading on this voltmeter has to be equal to 8.0 volts. So we can write down V across wire we also have. So value of V across wire is given to us, means the potential difference across wire, that is equal to 8.0 volts. Now we need to find out current. Now we need to understand how these quantities are linked together with current. So simply in this case you need to remember P is equal to V times I. V times I. So this is the power dissipated by wire, and this is potential difference across wire, and this is current passing through wire. Now we need to find out I passing through the wire. So simply we can say I is equal to P divided by V. So this one is V. So P in this case is 36 watts and the potential difference is 8.0 volts. So we can find out our final answer. In this case, final answer will be 4.5 amps up to 2 SF. Because our raw data has 2 SF, our final answer also must have 2 SF. So simply we can write down this is our final answer. And this question has 2 marks. The first mark you get if you have written this formula, means this equation, and this is C mark, you will get this. And the second mark is the answer mark. If you have got right answer, you will get 2 marks. Now the second part question is asking us to calculate the number of free electrons that pass through the resistance wire in a time of 50 seconds. First of all, let's try to calculate amount of charge passing through the wire in this given time. So we can simply calculate Q is equal to IT. So this is the amount of charge passing through wire in this given time. So we can plug in values of I and T. I we have calculated, that is equal to 4.5 amps, and time is given to us. This is equal to 50 seconds. Now if we solve this, our final answer is going to be 225 coulombs charge. Now we need to find out number of free electrons. Q simply in this case we need to understand Q is equal to number of free electrons times the charge on single electron. But for this question we need to calculate number of free electrons. So simply we can say this will be equal to Q over charge on single electron. Total charge is given to us, that is equal to 225 coulombs. We need to divide by charge on single electron, and charge on single electron is equal to 1.6 times 10 to negative 19. Now if we simplify this, our final answer is going to be 1.4 times 10 to 21, and this is the number of free electrons passing through resistance wire in 50 seconds. So this is our final answer. So we can write down this is 1.4 times 10 to 21. And this question has 2 marks. You will get the first mark, C mark, if you have got the right answer for amount of charge. And the second mark is answer mark. You will get 2 marks if you have got the right answer. For the next part, we need to calculate the resistance of the wire. So how we can find the resistance of the wire? So the best way to start this one is by writing what is given to us and what we have calculated for this wire. For this wire, power dissipated by the wire is given. That was equal to 36 volts. We have also found the potential difference across wire. That was equal to 8.0 volts. And we have calculated current in this wire. And that one was equal to 4.5 amps. So now we have different options to calculate resistance of the wire. So easy way to find resistance of the wire is we can simply say R is equal to V over I. So the resistance of the wire is equal to the potential difference across wire divided by current passing through the wire. So in this case, potential difference across wire is 8.0 and current passing through this wire is 4.5. So we can find our final answer. So in this case, final answer will be 1.8 ohms. So this is the resistance of the wire. But we can also calculate resistance of the wire by using this equation. P is equal to I square times R. So we can rearrange, we can calculate R, that will be equal to P divided by I square. So in this case, power is 36 and current is 4.5. Now if we solve this, we can find out value of resistance again. That one will be equal to 1.8 ohms. We can also calculate resistance of the wire by using the relationship between potential difference, power and resistance. So P is equal to V square. V is the potential difference across wire divided by resistance of wire. In this case, we need to find resistance of the wire. So simply we can say potential difference squared divided by P. This is equal to resistance. And now simply we can plug in values. Potential difference in this case is equal to 8.0. So we need to take square of that and we need to divide by the power. So our final answer will be 1.8 ohms. So you can use any method. We have discussed 3 different methods. You can use any one of them to calculate resistance of wire. This question has 2 marks. You will get the first mark if you have used the right equation. And the second mark means the 2 marks you will get if you have got the right answer. For part B, it is given to us the metal of the resistance wire in the circuit has a resistivity of 1.4 times 10 to negative 6 ohms meter. And cross-sectional area of the wire is equal to 0.25 millimeter square. We need to determine the length of the wire. So the best way to answer this question is first of all write down what is given to us and what we have calculated for this question. Resistivity of the wire is given, that is equal to 1.4 times 10 to negative 6 ohms meter. Cross-sectional area of the wire is given, that is equal to 0.25 millimeter square. But millimeter square is not SI unit. So we need to convert this one into SI unit. In order to convert this one into SI unit, we need to understand 1 millimeter is equal to 10 to negative 3 meters. But for this question, we have millimeter square. So we have to square on both sides. So simply in this case, 1 millimeter square will be equal to 10 to negative 6 meter square. So we can write down here 10 to negative 6 multiplied by 0.25 meter square. Simply you can write down in a proper way. You can write down this 0.25 times 10 to negative 6 meter square. But resistance of this wire we have already calculated in part A. Resistance of this wire is equal to 1.8 ohms. We need to calculate L, means length of the wire we need to calculate. So simply we can use the relationship between these quantities to calculate length of the wire. We need to understand resistance is equal to rho L by A. From here we can simply say L will be equal to R times A divided by resistivity. So we need to sub values here, mean we need to plug in values. So this is resistance of the wire, and cross-sectional area of the wire is 0.25 times 10 to negative 6, and we need to divide by resistivity. And resistivity is 1.4 times 10 to negative 6. If we solve this one, our final answer will be 0.32 meters up to 2 SF, because our raw data has 2 SF. So this is our final answer for this question. And this question has 2 marks. You will get first mark, C mark, if you have used the right formula. And the second mark you will get if you have got the right answer. I mean, if you got the right answer, you will get 2 marks. For part C, it is given to us the circuit shown in figure 6.1 is modified by replacing the original resistance wire with a second resistance wire. This is figure 6.1. So simply we can write on here the figure 6.1. The second wire has a greater diameter than the original wire. There are no other differences between the second wire and the original wire. By reference to resistance, we need to state and explain whether the power dissipated by the second wire is more than, less than, or the same as the power dissipated by the original wire. As in question, it is mentioned by reference to resistance. So first of all, we need to consider, is the resistance of the second wire, is it greater than the resistance of the first wire, or this resistance is less than resistance of first wire? So this is the point we need to understand. Is it greater, or is it less, or is it equal? So these things we have to consider. For the second wire, it is given to us that diameter is greater. So we can write down resistance is equal to rho L by A. And A is the cross-sectional area. We can write down cross-sectional area is equal to pi by 4 d square. Second wire has the same resistivity, and the length of the wire is also same. Mean resistivity of the second wire is the same, length is the same, but diameter has increased. If the diameter increase, it means resistance will decrease. So it means that resistance of the second wire is less than resistance of first wire. So simply we can say resistance of second wire is less than resistance of first wire. So this is very important piece of information about resistance. So we have to mention this one in our answer. Now we need to understand power dissipated. As the new wire is just placed across terminals of the power supply. So this is our new wire, and this is also connected across terminals of power supply. So it simply means that V is the same. So we can say V is the same, means the potential difference across wire is the same. V is the same, but the resistance is lower. So we can write down P is equal to V squared divided by R. If resistance is lower, it means the power dissipated in the wire is greater, because potential difference across wire is the same. So these points simply we need to mention. So first thing we can say, in this case, power dissipated is more than the first wire. So we can say more than first wire. So this is what you need to state, more than first wire, or you can say the previous wire. So more than first wire. So this is first point you can write. And the second point we can write down as the resistivity. We can also say as resistivity is the same, L is the same, but cross-sectional area is greater. It means the resistance is lower. As the resistance is lower, but potential difference is the same. So power dissipated is greater, because power dissipated is equal to V squared divided by R. If this is lower, this one has to be greater, because potential difference is the same. So these are the points you have to mention in your answer. Now let me show you how you can write down a proper answer. This is how you can write down your answer. In your answer, you have to mention power dissipated is greater. So this is one. The second one you have to mention as the length and resistivity are the same. Cross-sectional area is larger, so resistance is lower. And this is M mark, mean it has to be in your answer. Same potential difference across wire and lower resistance, so power dissipated is greater. For part D, it is given to us the circuit shown in figure 6.1 is modified by connecting a second battery of EMF 8.0 volts and battery has no internal resistance in parallel with the original battery and the original resistance wire as shown in figure 6.2. So this is our figure 6.2. In this case, you can see battery is connected in parallel with the previous one. By reference to the current in the resistance wire means current in this wire. We have to use this one as a reference. We need to state and explain whether the addition of the second battery causes the power in the original resistance wire to decrease, increase, or stay the same. Now, first of all, let's try to understand what is the effect of the second battery on current in this wire. So for that purpose, we need to understand Kirchhoff's second law. If we draw this loop, in this case, you can see potential difference across this wire does not change. So we can say V is equal to I times R. As potential difference across wire does not change, so it means current will also not change because resistance of the wire does not change. So simply from here we can say current in this case in this resistance wire will not change by connecting second battery. Now let's try to understand a little bit more about that. As this current in this wire is the same, but current coming from this battery, this will be I by 2, mean at this junction current I will split into two parts and current entering the second battery also will be equal to I by 2. So at this junction we can also say current entering is I by 2, so this is also I by 2, and current leaving, this one is I. We need to understand current entering or leaving any battery is always same. So current entering this battery is I by 2 and leaving is I by 2, and it is same for the second battery. Current entering and leaving is the same, and the total current passing through this wire is still I. So there is no change in current. So simply we can say, as in this case, V across the wire is the same, I across the wire is the same, so power stays the same because power dissipated by the wire is equal to V times I. So V is the same, I is the same, so power is the same. So we can simply write down in this case power stays the same. So this is how you can write down your answer. You can say power stays the same. So this is our statement. We can say power stays the same. Now we need to explain why power stays the same. We can simply say I means current in the wire is the same, and PD across wire means potential difference across wire, that is also same. So P is equal to VI, so power is also same. This question has 2 marks. You will get 2 marks if you have written right statement, means you have written this is right statement, you have mentioned power stays the same. So this is the answer mark. You will get 1 mark, but the second mark is M mark, means if you have written I is the same and you have written V is the same, and this is M mark. You must get M mark to get A mark. If you couldn't get M mark, you will also lose A mark, because first you need to get M mark and then you can get A mark. So this is must mark. First you need to get this one and then you can get A mark. Now let me show you the answer, how you can write down in a proper way. So this is how you can write down your answer. So let me clean. So this is how you can write down your answer. As you can see, this question has 2 marks. The first mark is M mark. So if you have mentioned current is the same, potential difference across wire is the same, so power stays the same.